Jedź prosto. Przygotuj się do skrętu w lewo. Skręć w lewo. Przygotuj się do skrętu w lewo. Skręć w lewo. Koniec trasy. Wybrano cel podróży. Skręć w prawo. Przygotuj się do skrętu w prawo. Skręć w prawo. Jedź prosto. Przygotuj się do skrętu w lewo. Skręć w lewo. Jedź prosto. prosto. Jedź prosto. Jedź prosto. Jedź prosto. Trzymaj się prawej strony, a następnie skręć w prawo. Skręć w prawo. Okej, ruszajmy. Trzymaj się prawej strony, a następnie skręć w prawo. Skręć w prawo. prosto. Jedź prosto. Znaleziono sygnał GPS, system gotowy do pracy. W drogę. Okej, ruszajmy. Skręć w prawo. Przygotuj się do skrętu w prawo. Skręć w prawo. Na rondzie zjedź pierwszym zjazdem. Zjedź z ronda. Na rondzie zjedź trzecim zjazdem. Zjedź z ronda. Na rondzie zjedź pierwszym zjazdem. Zjedź z ronda. Przygotuj się do skrętu w lewo. Skręć w lewo. Kolejna trasa za nami, oby więcej takich. Wybrano cel podróży. ale tam mieliśmy... Nieważne, znajdę nową trasę. Szukanie nowej trasy. W porządku, znajdziemy inną trasę. Przygotuj się do skrętu w prawo. Skręć w prawo. Na rondzie zjedź pierwszym zjazdem. Zjedź z ronda. Trzymaj się lewej strony, a następnie zjedź w lewo. Zjedź w lewo. prosto. Jedź prosto. Trzymaj się lewej strony. Trzymaj się lewej strony. Trzymaj się prawej strony, a następnie zjedź w prawo. Zjedź w prawo. Trzymaj się lewej strony.
The following is a conversation with Elon Musk. He's a simple algorithms waiting for the computation to improve.
Well, software guys have a thing that they call it the problem of early optimization.
Right.
So if you write a big software stack, and if you start optimizing like the first thing you write, the odds of that being the performance limiter is low.
Right.
But when you get the whole thing working, can you make it 2x faster by optimizing the right things? Sure. While you're optimizing that, could you have written a new software stack, which would have been a better choice? Maybe. Now you have creative tension. So,
but the whole time as you're doing the writing, that's the software we're talking about. The hardware underneath gets faster.
This goes back to the Moore's law. If Moore's law is going to continue, then your AI research should expect that to show up, and then you make a slightly different set of choices. Then we've hit the wall, nothing's going to happen, and from here it's just us rewriting algorithms. Like that seems like a failed strategy for the last 30 years of Moore's law's death. So
can you just linger on it? I think you've answered it, but I'll just ask the same dumb question over and over. So why do you think Moore's law is not going to die? Which is the most promising, exciting possibility of why it won't die in the next 5-10 years? So is it the continued shrinking of the transistor, or is it another S-curve that steps in and it totally sort of...
Well, shrinking the transistor is literally thousands of innovations.
Right, so there's
there's a whole bunch of S-curves just kind of running their course and being reinvented and new things. You know, the semiconductor fabricators and technologists have all announced what's called nanowires. So they took a fan which had a gate around it and turned that into little wires, so you have better control of that, and they're smaller. And then from there's some obvious steps about how to shrink that. The metallurgy around wire stacks and stuff has very obvious abilities to shrink. And you know, there's a whole combination of things there to do.
Your sense is that we're going to get a lot if this innovation from just that shrinking.
Yeah, like a factor of 100 is a lot.
Yeah, I would say that's incredible. And it's totally unknown.
It's only 10 or 15 years.
Now you're smarter, you might know, but to me it's totally unpredictable of what that 100x would bring in terms of the nature of the computation that people would be
Yeah, you're familiar with Bell's law. So for a long time it was mainframes, minis, workstation, PC, mobile. Moore's law drove faster, smaller computers. And then when we were thinking about Moore's law, Raja Gadori said every 10x generates a new computation. So scalar, vector, matrix, topological computation, right? And if you go look at the industry trends, there was mainframes and mini computers and PCs, and then the internet took off, and then we got mobile devices, and now we're building 5G wireless with 1 millisecond latency. And people are starting to think about the smart world where everything knows you, recognizes you. Like the transformations are going to be like unpredictable.
How does it make you feel that you're one of the key architects of this kind of future? So we're not talking about the architects of the high level people who build the Angry Bird apps and Snapchat.
Angry Bird apps. Who knows? Maybe that's the whole point of the universe.
I'm going to take a stand at that and the attention distracting nature of mobile phones. I'll take a stand. But anyway, in terms of
That matters.
the side effects of smartphones or the attention distraction, which part?
Well, who knows? Where this is all leading? It's changing so fast.
Wait, so back to
My parents used to yell at my sisters for hiding in the closet with a wired phone and dial. Stop talking to your friends all day.
Right.
Now my wife yells at my kids for talking to their friends all day on text. Looks the same to me.
It's echoes of the same thing. Okay, but you are one of the key people architecting the hardware of this future. How does that make you feel? Do you feel responsible? Do you feel excited?
So we're in a social context. So there's billions of people on this planet. There are literally millions of people working on technology. I feel lucky to be, doing what I do and getting paid for it. And there's an interest in it. But there's so many things going on in parallel. It's like the actions are so unpredictable. If I wasn't here, somebody else would do it. The vectors of all these different things are happening all the time. There's I'm sure some philosopher or meta-philosopher is, wondering about how we transform our world.
So you can't deny the fact that these tools, these tools are changing our world.
That's right.
Do you think it's changing for the better?
I read this thing recently. It said the two disciplines with the highest GRE scores in college are physics and philosophy, right? And they're both sort of trying to answer the question, why is there anything, right? And the philosophers, are on the kind of theological side, and the physicists are obviously on the material side. And there's 100 billion galaxies with 100 billion stars. It seems, repetitive at best. So there's on our way to 10 billion people. I mean, it's hard to say what it's all for, if that's what you're asking.
Yeah, I guess I am.
Things do tend to significantly increases in complexity. And I'm curious about how computation, like our world, our physical world, inherently generates mathematics. It's kind of obvious, right? So we have X, Y, Z coordinates. You take a sphere, you make it bigger. You get a surface that falls, grows by r squared. Like, it generally generates mathematics, and the mathematicians and the physicists have been having a lot of fun talking to each other for years. I mean, computation has been, let's say, relatively pedestrian. Like, computation in terms of mathematics has been doing binary algebra, while those guys have been gallivanting through the nether realms of possibility. Right? Now, recently, the computation lets you do mathematical computations that are sophisticated enough that nobody understands how the answers came out. Right?
Machine learning.
Machine learning. Yeah. Right? It used to be, you get a data set, you guess at a function. The function is considered physics if it's predictive of new functions, new data sets. Modern, you can take a large data set with no intuition about what it is and use machine learning to find a pattern that has no function. Right? And it can arrive at results that I don't know if they're completely mathematically describable. So computation has kind of done something interesting compared to A equal B plus C.
There's something reminiscent of that step from the basic operations of addition to taking a step towards neural networks that's reminiscent of what life on Earth at its origins was doing. Do you think we're creating sort of the next step in our evolution in creating artificial intelligence systems that will...
I don't know. There's so much in the universe already, it's hard to say.
Where we stand in this whole
Are
thing.
human beings working on additional abstraction layers and possibilities? Yeah, it appears so. Does that mean that human beings don't need dogs? No. Like there's so many things that are all simultaneously interesting and useful.
But you've seen, throughout your career, you've seen greater and greater level abstractions built in artificial machines, right? Do you think, when you look at humans, do you think that look of all life on Earth as a single organism building this thing, this machine with greater and greater levels of abstraction, do you think humans are at the peak, the top of the food chain in this long arc of history on Earth, or do you think we're just somewhere in the middle? Are we the basic functional operations of a CPU? Are we the C++ program, the Python program, or with the neural network? Or
like somebody's, people have calculated like how many operations does the brain do. Something, I've seen the number 10 to the 18th a bunch of times, arrive different ways. So could you make a computer that did 10 to the 20th operations?
Yes.
Sure.
Do you think
we're going to do that? Now, is there something magical about how brains compute things? I don't know. And my personal experience is interesting because you think you know how you think, and then you have all these ideas and you can't figure out how they happened. And if you meditate, what you can be aware of is interesting. So I don't know if brains are magical or not. The physical evidence says no. Lots of people's personal experience says yes. So what would be funny is if brains are magical, and yet we can make brains with more computation. I don't know what to say about that, but.
What do you think? Magic is an emergent phenomenon. What?
It could be. I have no explanation for it.
Let me ask Jim Keller of what in your view is consciousness?
What's consciousness?
Yeah, like what? Consciousness, love, things that are these deeply human things that seems to emerge from our brain. Is that something that we'll be able to encode in chips that get faster and faster and faster and faster?
Nobody really knows.
Can you summarize it in a couple of
words?
Sentences?
Many people have observed that organisms run at lots of different levels, right? If you had two neurons, somebody said you'd have one sensory neuron and one motor neuron, right? So we move towards things and away from things, and we have physical integrity and safety or not, right? And then if you look at the animal kingdom, you can see brains that are a little more complicated, and at some point there's a planning system, and then there's an emotional system that's, happy about being safe or unhappy about being threatened, right? And then our brains have massive numbers of structures, like planning and movement and thinking and feeling and drives and emotions. And we seem to have multiple layers of thinking systems. And we have a dream system that nobody understands whatsoever, which I find completely hilarious. And you can think in a way that those systems are more independent, and you can observe, the different parts of yourself can observe them. I don't know which one's magical. I don't know which one's not computational. So,
is it possible that it's all computation?
Probably. Is there a limit to computation? I don't think so.
Do you think the universe is a computer? Like you think?
It seems to be. It's a weird kind of computer, because if it was a computer, like when they do calculations on how much calculation it takes to describe quantum effects is unbelievably high. So if it was a computer, wouldn't you build it out of something that was easier to compute? Right, it's a funny system. But then the simulation guys have pointed out that the rules are kind of interesting. Like when you look really close, it's uncertain. And the speed of light says you can only look so far, and things can't be simultaneous, except for the odd entanglement problem where they seem to be. Like the rules are all kind of weird. And somebody said physics is like having 50 equations with 50 variables that define 50 variables. Like, like physics itself has been a shit show for thousands of years. It seems odd when you get to the corners of everything. It's either uncomputable or undefinable or uncertain.
It's almost like the designers of the simulation are trying to prevent us from understanding it perfectly.
But also the things that require calculations require so much calculation that our idea of the universe of a computer is absurd, because every single little bit of it takes all the computation in the universe to figure out. So that's a weird kind of computer. You say the simulation is running in a computer, which has, by definition, infinite computation.
Not infinite. Oh, you mean if the universe is infinite?
Yeah. Well, every little piece of our universe seems to take infinite computation to figure out.
Just a lot.
Well, a lot
Trzymaj
is
się
a pretty
prawej
big
strony,
number.
a
Compute
następnie
this
skręć
little
w
teeny
prawo.
spot, takes all the mass in the local 1 light year by 1 light year
Skręć w
space.
prawo.
It's close enough to influence.
What's a heck of a computer?
I know it's a weird description because the simulation description seems to break when you look closely at it. But the rules of the universe seem to imply something that seems a little arbitrary.
The universe, the whole thing, the laws of physics.
Yeah.
It just seems like how did it come out to be the way it is?
But lots of people talk about that. It's like I said, the two smartest groups of humans are working on the same problem.
From different
Aspects, and they're both complete failures. So
No.
that's kind of cool.
They might succeed eventually.
Well, after 2,000 years, the trend isn't good.
Well, 2,000 years is nothing in the span of the history of the universe, so
Sure.
we have some time.
The next 1,000 years doesn't look good either. So.
That's what everybody says at every stage, but with Moore's law, as you just described, not being dead, the exponential growth of technology, the future seems pretty incredible.
Well, it'll be interesting, that's for sure.
That's right. So what are your thoughts on Ray Kurzweil's sense that exponential improvement in technology will continue indefinitely? Is that how you see Moore's law? Do you see Moore's law more broadly, in the sense that technology of all kinds has a way of stacking S-curves on top of each other where it'll be exponential, and then we'll see all kinds of...
What does an exponential of 1 million mean? That's a pretty amazing number. And that's just for a local little piece of silicon. Now let's imagine you, say, decided to get 1,000 tons of silicon to collaborate in one computer at 1 million times the density. Now you're talking, I don't know, 10 to the 20th more computation power
Trzymaj
than our
się prawej
current
strony.
already unbelievably fast computers. Like, nobody knows what that's going to mean. The sci-fi guys call it, computronium. Like when a local civilization turns the nearby star into a computer. That's true, but...
So just even when you shrink the transistor,
that's only one dimension.
The ripple effects of that.
Like people tend to think about computers as a cost problem, right? So computers are made out of silicon and minor amounts of metals, and
Trzymaj się
this and
lewej
that.
strony.
None of those things cost any money. Like there's plenty of sand. Like you could just turn the beach into a little bit of ocean water in the computers. So all the cost is in the equipment to do it, and the trend on equipment is once you figure out how to build the equipment, the trend of cost is zero. Elon said first you figure out what configuration you want the atoms in, and then how to put them there. Right?
Yeah.
Because here's
right.
His great insight is people are how constrained. I have this thing, I know how it works, and then little tweaks to that will generate something, as opposed to what do I actually want, and then figure out how to build it. It's a very different mindset, and almost nobody has it, obviously.
Well, let me ask on that topic. You were one of the key early people in the development of autopilot, at least in the hardware side. Elon Musk believes that autopilot and vehicle autonomy, if you just look at that problem, can follow this kind of exponential improvement. In terms of the how question that we're talking about, there's no reason why it can't. What are your thoughts on this particular space of vehicle autonomy, and you're part of it, and Elon Musk's and Tesla's vision for vehicle
the
autonomy?
computer you need to build is straightforward. And you could argue, well, does it need to be 2 times faster, or 5 times, or 10 times? But that's just a matter of time or price in the short run. So that's not a big deal. You don't have to be especially smart to drive a car. So it's not like a super hard problem. I mean, the big problem with safety is attention, which computers are really good at, not skills.
Well, let me push back on one. You say everything you said is correct, but we as humans tend to take for granted how incredible our vision system is. So
you can drive a car with 20/50 vision. You can train a neural network to extract the distance of any object and the shape of any surface from a video and data.
yeah, but
It's really simple.
it's not simple.
That's a simple data problem.
It's not simple. It's because it's not just detecting objects, it's understanding the scene, and it's being able to do it in a way that doesn't make errors. So the beautiful thing about the human vision system and our entire brain around the whole thing is we're able to fill in the gaps. It's not just about perfectly detecting cars. It's inferring the occluded cars. It's trying to. It's understanding the.
I think that's mostly a data problem.
So you think with data, with compute, with improvement of computation, with improvement in collection.
Well, there's
of data,
when you're driving a car and somebody cuts you off, your brain has theories about why they did it. They're a bad person. They're distracted. They're dumb. You can listen to yourself.
Right.
So, if you think that narrative is important to be able to successfully drive a car, then current autopilot systems can't do it. But if cars are ballistic things with tracks and probabilistic changes of speed and direction, and roads are fixed and given, by the way, they don't change dynamically. Right? You can map the world really thoroughly. You can place every object really thoroughly. Right? You can calculate trajectories of things really thoroughly. Right?
But everything you said about really thoroughly has a different degree of difficulty. So
you could say at some point, computer autonomous systems will way better at things that humans are lousy at. They'll be better at attention. They'll always remember there was a pothole in the road that humans keep forgetting about. They'll remember that this set of roads has these weirdo lines on it that the computers figured out once, and especially if they get updates, so if somebody changes a given, like the key to robots and stuff, somebody said, is to maximize the givens. Right. So having a robot pick up this bottle cap is way easier if you put a red dot on the top, because then you have to figure out, if you want to do a certain thing with it, maximize the givens is the thing. And autonomous systems are happily maximizing the givens. Like humans, when you drive someplace new, you remember it because you're processing it the whole time. And after the 50th time you drove to work, you get to work, you don't know how you got there. Right? You're on autopilot. Right? Autonomous cars are always on autopilot. But the cars have no theories about why they got cut off or why they're in traffic.
So
they
that's
also never stop paying attention.
Right. So I tend to believe you do have to have theories, mental models of other people, especially with pedestrians and cyclists, but also with other cars. So everything you said is actually essential to driving. Driving is a lot more complicated than people realize, I think. So sort of to push back slightly, but
to cut into traffic, right?
Yeah.
You can't just wait for a gap. You have to be somewhat aggressive. Yeah. You'll be surprised how simple a calculation that is.
I may be on that particular point, but there's maybe I actually have to push back. I would be surprised. You know what? Yeah, I'll just say where I stand. I would be very surprised, but I think you might be surprised how complicated it is.
I tell people, like, progress disappoints in the short run, surprises in the long run.
It's very possible. Yeah,
I suspect in 10 years it'll be just like taken for granted.
Yeah, probably. But you're probably right.
It's going to be a $50 solution that nobody cares about. It's like GPS is like, wow, GPS is, we have satellites in space that tell you where your location is. It was a really big deal. Now everything has a GPS.
Yeah, it's true. But I do think that systems that involve human behavior are more complicated than we give them credit for. So we can do incredible things with technology that don't involve humans, but when you...
I think humans are less complicated than people, frequently subscribe.
Maybe I feel...
We tend to operate out of large numbers of patterns and just keep doing it over and over.
But I can't trust you because you're a human. That's something a human would say. But my hope is on the point you've made is, even if, no matter who's right, I'm hoping that there's a lot of things that humans aren't good at that machines are definitely good at, like you said, attention, things like that. Well, they'll be so much better that the overall picture of safety and autonomy will be, obviously cars will be safer, even if they're not as good at understanding.
I'm a big believer in safety. I mean, there are already the current safety systems like cruise control that doesn't let you run into people and lane keeping. There are so many features that you just look at the Pareto of accidents and knocking off like 80% of them super doable.
Na rondzie
Just to linger on the autopilot team and the efforts there, it seems to be that there's a very intense scrutiny by the media and the public in terms of safety, the pressure, the bar put before autonomous vehicles. What are your, sort of, as a person there working on the hardware, trying to build a system that builds a safe vehicle and so on, what was your sense about that pressure? Is it unfair? Is it expected of new technology?
Yeah, it seems reasonable. I was interested. I talked to both American and European regulators, and I was worried that the regulations would write into the rules technology solutions, like modern brake systems imply hydraulic brakes. So if you read the regulations, to meet the letter of the law for brakes, it sort of has to be hydraulic. And the regulator said they're interested in the use cases, like a head-on crash, an offset crash, don't hit pedestrians, don't run into people, don't leave the road, don't run a red light or a stoplight. They were very much into the scenarios, and and they had all the data about which scenarios injured or killed the most people, and for the most part, those conversations were like, what's the right thing to do to take the next step. Now, Elon's very interested also in the benefits of autonomous driving to free people's time and attention, as well as safety. And I think that's also an interesting thing. But building autonomous systems so they're safe and safer than people seemed, since the goal is to be 10x safer than people, having the bar to be safer than people and scrutinizing accidents seems philosophically correct. I think that's a good thing.
What are... It's different than the things you worked at, Intel, AMD, Apple, with autopilot chip design and hardware design. What are interesting or challenging aspects of building this specialized kind of computing system in the automotive space?
I mean, there's two tricks to building like an automotive computer. One is the software team, the machine learning team, is developing algorithms that are changing fast. So as you're building the accelerator, you have this worry or intuition that the algorithms will change enough that the accelerator will be the wrong one, right? And there's the generic thing, which is if you build a really good general purpose computer, say its performance is 1, and then GPU guys will deliver about 5x the performance for the same amount of silicon, because instead of discovering parallelism, you're given parallelism. And then special accelerators get another 2 to 5x on top of a GPU, because you say, I know the math is always 8-bit integers into 32-bit accumulators, and the operations are the subset of mathematical possibilities. So AI accelerators have a claimed performance benefit over GPUs because in the narrow math space, you're nailing the algorithm. Now, you still try to make it programmable, but the AI field is changing really fast. So there's a little creative tension there of, I want the acceleration afforded by specialization without being over-specialized, so that the new algorithm is so much more effective that you would have been better off on the GPU. So there is a tension there. To build a good computer for an application like automotive, there's all kinds of sensor inputs and safety processors and a bunch of stuff. So one of Elon's goals is to make it super affordable. Every car gets autopilot. So some of the recent startups you look at, and they have a server in the trunk, because they're saying, I'm going to build this autopilot computer that replaces the driver. So their cost budget's $10,000 or $20,000. And Elon's constraint was, I'm going to put one in every car, whether people buy autonomous driving or not. So the cost constraint he had in mind was great, right? And to hit that, you had to think about the system design. That's complicated. It's fun. It's craftsman's work. Like a violin maker, right? Yeah. You can say Stradivarius is this incredible thing. The musicians are incredible, but the guy making the violin, picked wood, and sanded it, and then he cut it, and he glued it, and he waited for the right day so that when he put the finish on it, it didn't, do something dumb. That's craftsman's work, right? You may be a genius craftsman because you have the best techniques and you discover a new one, but most engineering is craftsman's work, and humans really like to do that. You know, expression.
Smart humans.
No, everybody.
All humans.
I don't know. I dug ditches when I was in college. I got really good at it. Satisfying.
Yeah.
So
Digging ditches is also craftsman work.
yeah, of course. So there's an expression called complex mastery behavior. So when you're learning something, that's fun because you're learning something. When you do something that's rote and simple, it's not that satisfying. But if the steps that you have to do are complicated and you're good at them, it's satisfying to do them. And then if you're intrigued by it all, as you're doing them, you sometimes learn new things that you can raise your game. But craftsman's work is good. And engineers, like engineering is complicated enough that you have to learn a lot of skills, and then a lot of what you do is then craftsman's work, which is fun.
Trzymaj się
Autonomous
prawej
driving,
strony,
building
a
a very
następnie zjedź w prawo.
resource constrained computer, so a computer has to be cheap enough to put in every
Zjedź w
single
prawo.
car.
Yeah.
That essentially boils down to craftsman's work. It's engineering.
Yeah,
It's
you know, there's
innovation.
thoughtful decisions and problems to solve and trade-offs to make. Do you need 10 camera inputs or 8? You know, you're building for the current car or the next one. You know, how do you do the safety stuff? You know, there's a whole bunch of details. But it's fun. But it's not like I'm building a new type of neural network which has a new mathematics and a new computer to work. You know, that's like there's more invention than that. But the reduction to practice, once you pick the architecture, you look inside and what do you see? Adders and multipliers and memories and, you know, the basics. So computers is always this weird set of abstraction layers of ideas and thinking that reduction to practice is transistors and wires and, you know, pretty basic stuff. And that's an interesting phenomenon. By the way, like factory work, like lots of people think factory work is road assembly stuff. I've been on the assembly line. Like, the people who work there really like it. It's a really great job. It's really complicated. Putting cars together is hard, right? And the car is moving, and the parts are moving, and sometimes the parts are damaged, and you have to coordinate putting all the stuff together, and people are good at it. They're good at it. And I remember one day I went to work, and the line was shut down for some reason, and some of the guys sitting around were really bummed because they had reorganized a bunch of stuff and they were going to hit a new record for the number of cars built that day, and they were all gung-ho to do it. And these were big tough buggers, and, you know. But what they did was complicated.
Trzymaj się prawej strony.
Yeah, and I mean,
well, after a while you could, but you'd have to work your way up because, you know, like putting the bright, what's called the brights, the trim on a car on a moving assembly line where it has to be attached 25 places in a minute and a half is unbelievably complicated. And human beings can do it. It's really good. I think that's harder than driving a car, by the way.
putting together, working
in a factory.
Two smart people could disagree.
Yay.
I think driving a car.
We'll get you in the factory someday, and then we'll see how
No,
you do.
not for us humans. Driving a car is easy. I'm saying building a machine that drives a car is not easy. No, okay. Driving a car is easy for humans because we've been evolving for billions of years.
Drive cars. Yeah, I noticed
To do.
the Paleolithic cars are super cool.
Trzymaj się prawej strony.
Now you join the rest of the internet in mocking me.
Okay. I wasn't mocking you. I was just,
Yeah.
you know, intrigued by your anthropology.
Yeah, it's
I'll have to go dig into that.
There's some inaccuracies there. Yes. Okay, but in general, what have you learned in terms of thinking about passion, craftsmanship, tension, chaos, you know,
Jesus.
the whole mess of it? Well, what have you learned, have taken away from your time working with Elon Musk, working at Tesla, which is known to be a place of chaos, innovation, craftsmanship, and all
I really
those
like
things.
the way you thought. Like, you think you have an understanding about what first principles of something is, and then you talk to Elon about it, and you didn't scratch the surface. You know, he has a deep belief that no matter what you do is a local maximum. I had a friend, he invented a better electric motor, and it was like a lot better than what we were using. And one day he came by and said, you know, I'm a little disappointed because, you know, this is really great. You didn't seem that impressed. And I said, you know, when the super intelligent aliens come, are they going to be looking for you? Like, where is he? The guy who built the motor.
Yeah.
Probably not. You know, like but doing interesting work that's both innovative and, let's say, craftsman's work on the current thing is really satisfying. It's good, and that's cool. And then Elon was good at taking everything apart. Like, what's the deep first principle? Oh no, what's really that ability to look at it without assumptions and how constraints is super wild. You know, he built a rocket ship,
using that same
car,
process.
Everything. And that's super fun, and he's into it too. Like, when they first landed 2 SpaceX rockets in Tesla, we had a video projector in the big room, and like 500 people came down, and when they landed, everybody cheered. Some people cried. It was so cool. Right? But how did you do that? Well, it was super hard. And then people say, well, it's chaotic. Really? To get out of all your assumptions, you think that's not going to be unbelievably painful? And is Elon tough? Yeah, probably. Do people look back on it and say, boy, I'm really happy I had that experience to go take apart that many layers of assumptions? Sometimes super fun, sometimes painful.
So it could be emotionally and intellectually painful, that whole process of stripping away assumptions.
Yeah, imagine 99% of your thought process is protecting your self-conception. And 98% of that's wrong. Yeah. Now you got the math right. How do you think you're feeling when you get back into that one bit that's useful? And now you're open and you have the ability to do something different. I don't know if I got the math right. It might be 99.9, but it ain't 50.
Imagining it, the 50% is hard enough.
Yeah. Now, for a long time, I've suspected you could get better. Like, you can think better, you can think more clearly, you can take things apart. And there's lots of examples of that. People who do that. So.
And Elon is an example of that.
Apparently.
You are an example. So
I don't know if I am. I'm fun to talk to.
Certainly.
I've learned a lot of stuff.
Right.
Well, here's the other thing is, like, I joke, like I read books. Yeah. And people think, oh, you read books. Well, no, I've read a couple of books a week for 55 years.
Wow.
Well, maybe 50, because I didn't learn to read until I was 8 or something. And it turns out when people write books, they often take 20 years of their life where they passionately did something, reduce it to 200 pages. That's kind of fun. And then you go online and you can find out who wrote the best books and who, like, that's kind of wild. So there's this wild selection process, and then you can read it and, for the most part, understand it. And then you can go apply it. Like, I went to one company, I thought, I haven't managed much before. So I read 20 management books. And I started talking to them and basically compared to all the VPs running around. I'd read 19 more management books than anybody else. It wasn't even that hard. Yeah. And half the stuff worked, like, first time. It wasn't even rocket science.
But at the core of that is questioning the assumptions, or sort of entering the thinking, first principles thinking, sort of looking at the reality of the situation and using that knowledge, applying that knowledge. So
yeah, so I would say my brain has this idea that you can question first assumptions, but I can go days at a time and forget that, and you have to kind of like circle back to that observation.
Because it is emotionally
it's hard,
challenging.
Well, it's hard to just keep it front and center because you operate on so many levels all the time, and getting this done takes priority, or being happy takes priority, or screwing around takes priority. Like how you go through life is complicated.
Yeah.
And then you remember, oh yeah, I could really think first principles. Oh shit, that's tiring, but you do for a while, and that's kind of cool.
So just as a last question, in your sense, from the big picture, from the first principles, do you think, you kind of answered it already, but do you think autonomous driving is something we can solve on a timeline of years? So 1, 2, 3, 5, 10 years, as opposed to a century?
Yeah, definitely.
just to linger on it a little longer, where's the confidence coming from? Is it the fundamentals of the problem, the fundamentals of building the hardware and the software?
As a computational problem, understanding ballistics, roles, topography, it seems pretty solvable. I mean, and you can see this, you know, like speech recognition. For a long time, people are doing, you know, frequency and domain analysis and all kinds of stuff, and that didn't work at all, right? And then they did deep learning about it, and it worked great. And it took multiple iterations, and you know, autonomous driving is way past the frequency analysis point. You know, use radar, don't run into things. And the data gathering is going up, and the computation is going up, and the algorithm understanding is going up, and there's a whole bunch of problems getting solved like that.
The data side is really powerful, but I disagree with both you and Elon. I'll tell Elon once again, as I did before, that when you add human beings into the picture, it's no longer a ballistics problem. It's something more complicated, but I could be very well proven wrong.
And cars are highly damped in terms of rate of change. Like the steering system is really slow compared to a computer. The acceleration is really slow.
Yeah, on a certain time scale, on a ballistics time scale, but human behavior, I don't know. I shouldn't say.
Human beings are really slow too. Weirdly, we operate, you know, half a second behind reality. Nobody really understands that one either. It's pretty funny.
Yeah.
So, yeah,
we very well could be surprised. And I think with the rate of improvement on all aspects, on both the compute and the software and the hardware, there's going to be pleasant surprises all over the place. Speaking of unpleasant surprises, many people have worries about a singularity in the development of AI. Forgive me for such questions.
Yeah.
When AI improves exponentially and reaches a point of superhuman level general intelligence, you know, beyond the point, there's no looking back. Do you share this worry of existential threats from artificial intelligence, from computers becoming superhuman level intelligent?
No, not really. You know, like we already have a very stratified society. And then if you look at the whole animal kingdom of capabilities and abilities and interests, and, you know, smart people have their niche, and, you know, normal people have their niche, and craftsmen have their niche, and, you know, animals have their niche. I suspect that the domains of interest for things that, you know, astronomically different, like the whole something got 10 times smarter than us and wanted to track us all down because what? We like to have coffee at Starbucks. Like, it doesn't seem plausible. Now, is there an existential problem that, how do you live in a world where there's something way smarter than you, and you base your kind of self-esteem on being the smartest local person? Well, there's what, 0.1% of the population who thinks that, because the rest of the population's been dealing with it since they were born. So the breadth of possible experience that can be interesting is really big. And, you know, super intelligence seems likely, although we still don't know if we're magical, but I suspect we're not. And it seems likely that it'll create possibilities that are interesting for us, and its interests will be interesting for that, for whatever it is. It's not obvious why its interests would somehow want to fight over some square foot of dirt, or, you know, whatever, you know, the usual fears are about.
So you don't think you'll inherit some of the darker aspects of human nature?
Depends on how you think reality's constructed. So for whatever reason, human beings are in, let's say, creative tension and opposition with both our good and bad forces. Like, there's lots of philosophical understanding of that, right? I don't know why that would be different.
So you think the evil is necessary for the good? I mean, the tension.
I don't know about evil, but like, we live in a competitive world where your good is somebody else's, you know, evil. You know, there's the malignant part of it, but that seems to be self-limiting, although occasionally it's super horrible.
But yes, there's a debate over ideas, and some people have different beliefs, and that debate itself is a process. So at arriving at something.
Yeah, and why wouldn't that continue?
Yeah. But you don't think that whole process will leave humans behind in a way that's painful? Emotionally painful, yes. For the 0.1%, they'll be.
Why isn't it already painful for a large percentage of the population? And it is. I mean, society does have a lot of stress in it about the 1% and about the this and about the that. But everybody has a lot of stress in their life about what they find satisfying, and know yourself seems to be the proper dictum. And pursue something that makes your life meaningful seems proper. And there's so many avenues on that. Like, there's so much unexplored space at every single level. I'm somewhat my nephew called me a jaded optimist. And, so
there's a beautiful tension in that label. But if you were to look back at your life and could relive a set of moments, because they were the happiest times of your life outside of family, what would that be?
I don't want to relive any moments. I like that. I like that situation where you have some amount of optimism and then the anxiety of the unknown.
So you love the unknown, the mystery of it.
I don't know about the mystery. It sure gets your blood pumping.
What do you think is the meaning of this whole thing? Of life? On this pale blue dot?
It seems to be what it does. Like, the universe, for whatever reason, makes atoms, which makes us, which we do stuff. And we figure out things, and we explore things, and...
That's just what it is.
It's not just.
Yeah, it is.
Yeah.
Jim, I don't think there's a better place to end it. It's a huge honor. And,
well, that's super fun.
Thank you so much for talking today.
All right, great.
Thanks for listening to this conversation, and thank you to our presenting sponsor, Cash App. Download it, use code LEXPODCAST. You'll get $10, and $10 will go to First, a STEM education nonprofit that inspires hundreds of thousands of young minds to become future leaders and innovators. If you enjoy this podcast, subscribe on YouTube, give it 5 stars on Apple Podcasts, follow on Spotify, support it on Patreon, or simply connect with me on Twitter. And now, let me leave you with some words of wisdom from Gordon Moore. If everything you try works, you aren't trying hard enough. Thank you for listening, and hope to see you next time.